Hey everybody, I miss you guys terribly. So we are up to the 2017 FRQs. As you probably guessed, we'll go through 2018 and 19 and then we'll be done with this. In this packet we're only going to do problems 1 through 4 because number 5 is a chi-square, which is not on this year's test. Which I'm still sad about, just saying. Okay. So let's go through the scoring part of number 1, and I am really glad this came up because I'm not really sure that any of you out there would be super confident explaining what positive means, what linear means, and what strong means. As a matter of fact, I think I got strong. I did not write a good enough answer for strong, so we're going to check that as we go. I might have gotten a P on that section. But anyway, let's begin. Okay, so for part A is scored as follows. You get an E if you have these 4 components: a reasonable definition of positive, a reasonable definition of linear, a reasonable definition of strong, and at least one of them is in context, so mention something about wolves or how is this, kilograms, meters, something like that. Okay, in the scoring guidelines, and you get a P, by the way, if you only have 3 of the 4, and then an I for anything other than that. Here are my answers. This answer is completely fine. Wolves with higher value in length tend to have higher values in weight. So they've given us some examples of acceptable responses. Let's see if I can zoom in on this a tiny bit. Okay. As length increases, so does weight. Longer wolves weigh more. The points on the graph go up as you move from left to right. Okay, so any of those things are an acceptable description of positive. You cannot say as length goes up, weight changes, because that doesn't have the direction of going up. Both length and weight get bigger. Bigger does not imply going up, because it just doesn't. The correlation is greater than 0. Okay, it doesn't want that either. So wolves with higher value tend to have higher value in weight. This might be kind of challenging for you guys. I found this challenging when I first did it because I know how to tell if it's positive, linear, and strong, but just like explaining why it's positive, linear, and strong, I don't think is something we did a whole lot of. Okay. For linear, I put as wolf length increases for each meter, weight tends to increase at a constant rate. So constant rate, I think, is the key there. Here are the acceptable responses. The points generally follow a straight line. Okay, I bet a lot of you guys put that. The relationship between x and y is straight. Length and weight have a constant slope. Okay, so I said constant rate, so I'm good there. The points all line up, not okay. You can draw a straight line through the points, not okay. There's a positive correlation, not okay. Every increase in x yields a 35.02 increase in y. That is the kind of the interpretation of slope, so they don't want that. Hopefully you guys put the points generally follow a straight line, like that's the most straightforward of that. Okay, strong. Okay, so I think I did not put a good enough answer here. I said the data points fall close to a line or curve. They wanted more about like residuals, so observed values are close to predicted values. Deviations from the least squares regression line are small. The correlation coefficient is close to 1. Those are okay. What's not okay is all the points are close together. The scatter plots are clustered together. There's a high positive correlation. It's not okay. So it says the description of strong should indicate how close points are to a line. I just said the data points fall close to a line or curve. I don't know. You might give me a P, you might give me an E on that. I'll let you decide. But anyway, I'm not sure I love my description there. Okay, part B. Essentially correct if the response includes the following three components. The correct value of 35.02 for the slope. Increase of a specified amount of weight for each unit gives an increase in length. And you use somewhere the word predicted or on average. So you're indicating that it's not exact. If you use our description from class, you'll get an E from this. For every increase in 1 meter of length, we predict an increase of weight of 35.02 kilograms. There's my 35.02. There's my increase in length, increase in weight, and then I used predict. Okay, a P for this section would have 2 of the 3 of those components. And if you accidentally put negative 16.46 as the slope, and you put 1 meter increase in length, there's a decrease in average weight of 16.46. You can get a P on this, although thinking about the weight of a wolf going down as they get bigger is, you know, kind of strange. But anyway, you can get a P, and incorrect if it's anything else. So there's that. And then part C, you need to have 2 things for an E: a correct computation of the predicted value of 32.568. Mine's a little off. Oh, I just rounded. Okay. And then a correct computation for the actual weight of 22.9 kilograms using the given residual and the predicted value. Okay, so I have the 1.4 plugged in to the equation, 32.57, and then I use the equation residual equals actual minus predicted to solve for the actual of 22.9. My response is an E. You get a P if you did the correct predicted value, so you got the 32.57, but you were unable to get the actual weight. So I think that's nice. You get partial at least. I know the actual weight was harder to find. If you use an incorrect value for the predicted weight, but then use the value correctly to determine the actual weight. So for example, this is wrong, but you use that wrong answer here, and this is correct for your wrong answer, you can still get a P, which is great. And you don't show your work, you get a P. Here are some notes. If you put this is good enough for the first component, you don't actually have to write the answer. And if you put that into minus 9.67 equals that, you can satisfy both components in one equation, which is pretty cool. Okay, that is it for question 1. Question 2, I'm hoping everyone gets an E on this one. This is a super easy confidence interval. Okay, so there are 4 sections that need to be graded on this problem. The first 3 sections have to do with the interval itself, and then the 4th section is this kind of plugging in thing for B. Okay, so section 1, you get an E if you identify it as a 1 sample Z interval for a proportion, either by name or by formula. So by me having this formula here, that constitutes an E, even though I didn't say it was a 1 sample Z interval for a proportion. And both conditions, random sampling and large sample, are adequately addressed. So I identified it by formula, random sample, and then I did n times p is greater than or equal to 10, and so successes and failures greater than or equal to 10. It did not count the independence condition because this 800, this might not be true, but anyway. Okay, You get the P if you identify the correct procedure but only one of the two required conditions, or if you don't identify the correct procedure but you adequately address both of the conditions, then you get a P. High as anything else. Okay, section 2. You get an E if you have the correct 95% confidence interval. People who are lazy, don't read this next sentence. Supporting work is not required, but if included, it must be correct. Okay, here's the thing. You needed to show the work for the formula, regardless, to get the credit for the previous problem. I have marker all over my hand. So you need to show your work. Just show your work anyway. Just ignore that. I shouldn't have highlighted it. I should have just glossed over it. Okay, you get a P if the correct confidence interval with incorrect or but appropriate supporting work shown. Partially correct. Oh, so if you have incorrect work shown, but you have the correct confidence interval. I don't know how that would happen, but all right. You can also get a P if you have an incorrect but reasonable interval with appropriate supporting work shown. So for example, if a value other than 1.96 is used for a critical value, or a value other than 23/80 is used for P hat. Okay. So here's an interesting fact. A confidence interval that is both endpoints outside of the interval from 0 to 1 is considered unreasonable. So what they're saying is you should know that this is a proportion, so these should be proportions. Okay, so section 2, if I lost you in my wording, you needed to have the correct confidence interval and your supporting work needed to be correct. Okay. Section 3. You get an E if you have the following 3 components. Conveys inference about a population proportion. The parameter is the proportion of water cup population that fills the cup with a soft drink. Mentions 95% confidence and interprets it correctly using words as we can be 95% confident or with 95% confidence. Okay, if you just follow our usual conclusion, then you will get an E on that section. And for a P, you have to satisfy the first component and only one of the second or third. And this is interesting. I wanted to point this out. If you can't figure out how to do the interval, and you just interpret it properly in context without the actual interval, you can still get a P. So we are 95% confident that an interval will capture the, so you can still get a P there without any math, which is great. Okay, last section for this, you get an E if you give the correct interval estimate for the cost of the restaurant and show enough work to indicate how the interval was found. Okay, so for me, I multiplied the 2 endpoints of my interval by 3,000 customers, and then I multiplied it by 25 cents for the soft drink, and I have my new endpoint is 141.23 to 290.03. Okay, I'm sure that you can guess. You can get a P if you either multiply by 3,000 or multiply by 0.25, but not both. And you can also get a P if you accidentally use a sample size of 80 instead of 3,000. Now back to the work thing. It says you get a P if you have the correct interval without showing how it was found. So if you don't have this supporting work, you get a P. Up here, just having the interval, you can get an E. But I don't know. Just show your work, please. Please, 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 just show your work. Show it. Show all of it. Every bit of it. Okay. Number 3, and I know a lot of you guys indicated that you needed to work on this probability stuff, so here's a really great opportunity to practice this. Okay. Now, this is really interesting. It says you get an E for part A if you indicate use of a normal distribution and clearly identify the correct parameter values. Okay, showing correct components in a z-score, labeling the mean and standard deviation in a normal CDF calculator statement, or drawing a normal curve will work for that. So notice I have my mean and standard deviation labeled. I don't know if you guys, hopefully you looked at the resources page that I posted on Google Classroom. It has tips for keyboarding, and in the keyboarding language they want you to put normal CDF lower bound equals 137, upper bound equals 10 to the 99, mean equals 133, standard deviation equals 5 in the parentheses right there. Definitely go take a look at that. Oh, who is it? It's a telemarketer. Shocking.
Call from unavailable.
Okay. Next thing you need to
Call
have for an
from
E
unavailable.
is to use the correct boundary value of 137 and the correct direction. Okay, you can actually satisfy this with this part. So I have the boundary level of 137 and greater than, and hopefully you guys are defining your random variable at the beginning still, not getting lazy and forgetting to do that. I believe this also indicates direction, but I think you have to label it as we were talking about earlier. And then the third component is the correct probability, so 0.2119. Okay. And part B, okay, part B says you get an E if your probability is computed correctly and work is shown that includes correct numerical values using a formula and results from a tree diagram or some other appropriate method, which is a table for us. So you guys might have done a table for this. That's totally fine. So here is my correct answer resulting from my tree diagram. You get a P if you have the correct strategy but one or more incorrect values. And you give the correct probability but not enough work was shown. Here is the table. So if any of you did the table, here are the values from the table. This counts as work. Okay. So just, a note. Remember, you multiply down the branches and then add up the ones you want. Okay. Part C is a conditional probability, and you get an E if the probability is computed correctly and work is shown that illustrates how the probability was found. Okay, so what it wants is this in the numerator and this in the denominator and this in the answer. And as long as you have that, you'll get an E. It wants to see where this came from, where that came from. Okay. You get a P if you have a strategy but uses one or more incorrect values or does not use the end result from the tree. Okay, so what I want to mention is if you go back, if you look at the notes for this section, you get an E actually if you get a correct answer following from incorrect values used from part A or part B, provided that all values are between 0 and 1 inclusive. Okay, what it means is you can get something in here wrong, you can get this wrong, but if you use that number correctly in part C, you can still get full credit. So, anyway, for this section, you can get a P if you Also have the correct probability but not enough work is shown. So if you just write this, but you don't have the correct numerator and denominator there. Okay, one more and then we're done with this video. Okay, I think I just have a feeling that you guys probably didn't love this question. The graph is confusing. It's a little bit, it's just kind of a lot. Okay, describe how the percents and the pieces of pottery are similar and how they differ. Okay, so what they wanted you to do was notice that the medians or the centers are almost the same for the 3 sites, but that variability, either range, IQR, or spread, is different for the 3 sites, and that you have some kind of context. If you only do 2 of the 3 components, you get a P. 1 of the 3 components is an I. So I said the medians for all 3 sites are similar at about 7% of total weight. The IQRs, and you could have done spread, range, for all 3 sites are different at about 4% total weight for 1, 0.5 for 2, and 4 for 3. Okay. Now part B, it's actually section 2 in the grading, in the scoring guidelines. Essentially correct if the response includes the following 3 components. You chose site 3, you have to choose site 3. Sums of the minimum and maximum are computed for the 3 chemicals at each site. A reasonable numeric justification is given involving sums of statistical measure across the 3 chemicals to choose the site 3. Okay, I just lost you. I know I just lost you with that. Okay, so I put site 1 has a minimum percentage of, and then I showed the sum, so I showed my work. So this is my numerical component showing sums. And a maximum of 33, so it was not manufactured here. Site 2 has a minimum percentage of about 13 and a maximum of 17, so it wasn't manufactured here. Site 3 has a minimum of 14 and a maximum of about 26.5, so it was most likely manufactured here. Okay, I think I got a P on this, and the reason is because I didn't do this. A reasonable numerical justification is given. What I didn't do was I didn't mention the number 20.5%. I did not say that 20.5% is in between 14 and 26.5, so it was most likely manufactured here. It might depend on the reader. Think again, someone might give me an E, someone might give me a P. But in my own kind of analysis of this, I feel like I didn't mention that 20.5, and so I would get a P. Okay, section 3. Essentially correct if the response chooses chemical Y and gives a reasonable justification based on the fact that the distributions of chemical Y are distinctive across sites, and what that means is distinctive means they don't overlap. So I said chemical Y would be the most useful because the box plots for site 1, 2, and 3 do not overlap, so that's that distinctive piece there. You get a P if you choose chemical Y, but don't say that they are clearly don't overlap, or if you say that they overlap but don't ever actually choose chemical Y as your best choice. So you need to make a decision and explain why, because they don't overlap. Okay, everyone, so that was 2017. And we have 2 more, and then we're done. I'll talk to you guys soon. Bye.